Hey guys, a while back I got a giant 36-inch CRT television for free off of Craigslist, and since I don't really watch TV, I removed the flyback transformer. In this video, we'll see if we can make a high voltage power supply with this transformer. Let's get started. The first thing we need to do is decide what driver circuit we wish to use in our power supply. There are many ways to drive a flyback transformer, such as a zero voltage switch, IGBT, and 2N3055 driver, among others, which, in simple terms, store energy in the transformer's ferrite core before releasing it to the secondary coil. For this power supply, however, I will simply use a fluorescent light ballast like in my other video. Great video, by the way, if you wish to understand how a flyback transformer works. Anyway, to connect the ballast to the transformer, all you have to do is connect two wires that go to opposite ends of a fluorescent tube, as shown by this diagram, to the primary coil of the transformer. The primary coil usually has a resistance close to 1 ohm. Once we have connections done, we connect a power cord to the black and white wires coming out of the ballast, and we can now plug it in. Before that, I'd like to state that this transformer has 3 possible outputs. Between the anodial cap and this wire that I've soldered to the transformer is a very high voltage of about 45,000 volts. With about 4 milliamps at short circuit. Between the anodial cap and this next wire is a relatively high voltage of about 35,000 volts, with a higher current at short circuit of about 50 milliamps. Finally, between these two wires is about 15 kilovolts, but that can deliver about 100 milliamps at short circuit. Anyway, let's just plug it in. We'll start with the 45 kilovolts. Now the 35 kilovolts. Finally, the 15 kilovolts. As you saw, that transformer can do tens of thousands of volts and can deliver a large amount of current. In fact, I would say that last couple of wires was better than most CBS drivers. Still though, it is still somewhat boring, and I believe that this transformer can do much better. In order to improve the output of this transformer, I will install a resonant capacitor across the primary coil. A resonant capacitor would lower the impedance of the circuit substantially, and would also tune the oscillations of the primary coil to a certain frequency. The response of the circuit to signals of different frequencies is a function of the capacitance and the inductance of the circuit, and peaks at one frequency value, at which the current flow resonates most strongly with the input signal. Resonant circuits are used in radio and television tuners to pick out broadcast signals of specific frequencies. They are also used in Tesla coils to, as I've mentioned before, tune the frequency of the oscillations. The result should be an increase in circuit efficiency, leading to a larger amount of current which the circuit can deliver. Let's give it a try. For my resonant capacitor, I will be using a 1 nanofarad 15 kilovolt capacitor. I recommend using a high voltage capacitor in order for it to be protected from high voltage spikes. Alright, I've installed the resonant capacitor, so let's give it a try. First, the 45 kilovolts. Wow, that is so much better than the original. Amazing. Now the 35 kilovolts. Wow, that is definitely much better. And finally, the 15 kilovolts. I can't wait to see what absurd amount of current this thing can deliver. Wow! That's amazing. Although I would not want to get shocked by that. You'd get third-degree burns at least. We now discharge the high-voltage capacitor. As you saw, the resonant capacitor had a large effect on the efficiency of the circuit. Oh yeah, that's another thing. The circuit isn't actually drawing any more power now that it has the resonant capacitor across the primary coil. It's just that a larger percentage of that power is getting to the secondary coil. If you have a flyback transformer, I definitely recommend adding a resonant capacitor, as it makes this power supply way better. Anyway, that's it for today. Thanks for watching.